Hello everyone, welcome to Intellify. Today's topic is conservation of momentum that comes under the chapter Force and Laws of Motion, subject Science and class 9. We first come to the law of conservation of momentum. It states that the total momentum before a collision is equal to the total momentum after the collision if no external forces act on the system. So what is it exactly? We'll see in the next slide. So there are two balls we can see. One is of mass ma and the other is of mass mb. The ball with mass ma moves with a velocity of ua and the ball with the mass mb moves with a velocity of ub. And after it collides each other, the ball A exerts a force FAB on ball B. And similarly, the ball B exerts a force FBA on ball A. So, after collision, what happens? The first body with the mass MA moves with the velocity VA, and the second body, that is with the mass MB, moves with the velocity VB. The first ball has a mass of ma and its initial velocity is ua and its final velocity is va. So we can say that the rate of change of its momentum during its collision will be ma into va minus ua. This va minus ua is the change in the velocity divided by t. As it says the rate, it means that it is divided by time. And this rate of change of momentum is known as force. And similarly, the rate of change of momentum of ball B or FBA will be MB into VB minus UB. This VB minus UB is the difference in the velocity of the final and the initial velocity, and it is also divided by T. And we know, according to the third law of motion, the force FAB, that is exerted by ball A on ball B, and the force BA, that is FBA, that is exerted by the ball B on ball A, will be equal as well as opposite to each other. So we have written it over here that FAB is equal to minus FBA, and this is the FAB and this is FBA. So we write it over here, and after calculating, what we get is MA into UA plus MB into UB is equal to MA into VA plus MB into VB. So it states that the initial momentum of two bodies is equal to the final momentum of the two bodies after the collision happens. So there is a problem that states that a bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. So what is the recoil velocity of the pistol? So this 20 gram is 0.02 kg. So here we need the total momentum of the pistol and bullet before the fire. And the gun is at rest. So 2 plus 0.02, which is the mass of the pistol and the bullet, into 0 meter per second, because the gun is at rest. So it gives us 0 kg meter per second. And the total momenta of the pistol and bullet after it is fired is 0.02 kg, that is the mass of the bullet, into 150 meter per second. 150 meter per second is the velocity as it is given, plus 2 kg into v meter per second. Now 2 kg is the mass of the pistol and v is the recoil velocity of the pistol, which has been assumed by us. So according to the law of conservation of momentum, the total momenta after the fire will be equal to the total momenta before the fire. So 3 plus 2v is equal to 0, which gives us v equal to minus 1.5 meter per second. And this negative sign indicates that the direction in which the pistol would recoil is opposite to that of the bullet. Then we come to another problem which states that a girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the cart is 3 kg What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. So we first calculate the total momentum of the girl and the cart before the interaction. So it's 40 into 5, because 40, it's given that the mass of the girl is 40 kg and her velocity is 5 meter per second. So we have multiplied it to get the momentum of the girl, and 3 into 0 is the momentum of the cart, because it's 3 kg is the weight of the cart and 0 as in it's not moving. So the total we get is 200 kg meter per second. The total momentum after the interaction is 40 plus 3, because this is the total weight of the girl and the cart, and v meter per second. This v, as we know, is the velocity of the girl in the moving cart. It gives us 43 v kg meter per second. And so now we will use the law of conservation of momentum. And so by this law of conservation of momentum, what we can say is this 43v is equal to this 200. And this gives us v is equal to plus 4.65 meter per second. So the girl on the cart would move with a velocity of 4.65 meter per second in the direction in which the girl has jumped. Thank you.